Hi guys, welcome again to Simplified RSA. The guys makes it looks easy. And we are back again with another exciting topic that can assist someone when they are doing their homework. Either you are writing your assignments, preparing for an exam, or just a test. And our today's topic is going to be quadratic sequence. We're not going to start with sequence and series from the beginning, but then it's just another topic under sequence and series. If you've been following our videos at this point, everyone is expected to at least understand how to get the nth term of an arithmetic sequence or a geometric sequence. If you don't know what I'm talking about at this point, feel free to pause this video from here, go back and watch a video that says the topic of the video is Introduction to Sequence and Series in order to keep up with today's topic. So like I say, at this point, you are expected to know how to calculate the nth term for an arithmetic sequence or a geometric sequence for you to continue watching this video. If not, then you can pause from here and then go watch the video introducing the topic. Otherwise, under arithmetic sequence, we get the sequence as it is, and then we get our common difference, and then our common difference has to be the same for us to conclude that the sequence is indeed an arithmetic sequence. However, now that we are introducing the so-called quadratic sequence, under quadratic sequence, we're going to have our sequence like that. When we try to get the common difference, we're going to have our first common difference not to be constant. Only when we try to get our second difference, we're going to find our second difference to be different. So to define whether a sequence is quadratic sequence or not is if only the second common difference is constant. The first common difference forms another type of a sequence, which you have to get another common difference again. I know it might not make sense when I say it like this, but then let's just try to scribble it down. So if we had this arithmetic sequence and we're trying to get the difference between that and that, 11 minus 4 is going to give us 11 minus 4 is going to give us 7. 20 minus 11, 20 minus 11 is going to give us 9. Let me just rewrite the sequence to show there. So we have 7, we have 9, we have 11, and 13. So when trying to get the common difference here, we got 11 minus 4 gave us a 7, 20 minus 11 gave us a 9, 31 minus 20 gave us 11, and 44 minus 31 gave us 13. This was supposed to be the same if this was an arithmetic sequence, but then somehow we formed another sequence there. So we're going to say this is our first difference. This is our first common difference. And then to get the second common difference, it's going to be like this. 9 minus 7 will give me 2. 11 minus 9 will give me 2. 13 minus 11 will give me 2. Now, the second difference is constant. Now, the second difference is constant. So this is the first property of how we tell if a sequence is a quadratic sequence. So you can see that we have a sequence that seems like an arithmetic sequence. However, when we try to get the common difference, the first common difference is not constant. And then we get the second common difference, and then the second common difference is the same, whereby we say it is constant. So the first property of knowing if you are dealing with a quadratic sequence is if the second common difference is the one that is constant instead of the first one. The second property is that the nth term of this sequence has to be a quadratic function, like it has to form a quadratic function of some sort. This is what I mean. So the nth term has to form a quadratic function of some sort. So it has to form a quadratic function. So this is how we show a quadratic function. So this sequence, the nth term of this sequence, it must be in the form of an squared plus bn plus c. Now, the challenge in this type of equation is just to find the value of a, b, and c, and then substitute on that question there. So the interesting part about today's topic, which is actually the punchline, is I'm not going to just show you one, but I'll show you two different ways of how to get your nth term of a quadratic sequence. So now, without wasting time, let me show you the first one. And then it's going to depend on between the first one or the second one, which one do you find it easy? And then that's going to be your way of getting your nth term of a quadratic sequence. So let's do the first method. So finding the nth method of this sequence is just finding a way to represent the nth term in the form of this, because we know this is a quadratic sequence, because we've proved that by showing that the second difference is constant. And we must now represent this sequence in the form of this. That would be our nth term. So now, meaning we must get the value of A, B, and C. The first method, they say you must get half of the common difference. You must have this. You must have this. So if you have 2, half of 2 is 1. So half of 2 is 1. So half of 2 is our A. So meaning we're going to say we have n squared. If this was 4, then we're going to say half of 4 is 2. That's when we're going to say is 2n squared. If this was 6, we're going to say half of 6 is 3, and then we're going to have 3n squared. That's how we go with the first term. So now we've had our first term. We know that n squared is our first term. So we know that A is 1, n squared is our first term. Now to find B and C, we first must write the original sequence. So we're just going to write our original sequence aside here. And then after writing our original sequence, and then we're going to determine n squared. We're going to determine n squared. Meaning if it was the case where we had found 2n squared, we would be determining 2n squared here. But then now we are just going to determine n squared. N squared meaning the first term, if I put 1 into there, I'll get 1. N squared, if I put 2 into n, I'll get 4, because 2 squared is 4. If I put 3 on n, I'll get 9, because 3 squared is 9. If I put 4, I'll get 16. And if I put 5, I'll get 25. And then from there, the next step is to subtract. So like I say, the next step is to subtract. 4 minus 1 will give us 3. 11 minus 4 will give us 7. 20 minus 9 will give us 11. 31 minus 16 will give us 15. And then 44 minus 25 will give us 19. So that's our new sequence. We get the new sequence from subtracting the original from n squared. So step number 1, we get half of the second difference. Half of the second difference, we got it to be 1. And then we say, that's how we determine our n. So we know that if it's 1, we know that A is 1. So it's going to be n squared. Hence, we have our n squared. Now, we want to get the other part. We want to get the other part of the quadratic equation using this sequence now. Now, from here, we just find our nth term the way we used to know. We just find our nth term according to arithmetic. We just find our arithmetic nth term here. To do that, we have to find the difference, obviously. And if we find the difference, one can see that the difference throughout here, the difference between 7 and 3 is going to be 4, obviously. And the difference between 11 and 7 is also 4 because 11 minus 7 is 4. And then the difference between 11 and 15 is 4. And then the difference there is 4 as well, meaning we have 4n as our standard. But then we have to get the value of C. We must determine what was the value here before the first term. What was the value here before the first term? To get what was the value here before the first term, we must know what must we add with 4. If n is 1, what must be added with 4 in order to get 3? And then the answer to that obviously will be, in fact, to get that, you can just say what must be added with 4 in order to get 3 for the next term. Therefore, it's going to be 3. If I take that to the other side, it's going to be minus 4 will be minus 1. So it has to be minus 1. And indeed, if I put 1 there, if I put 1 on 4, 4 minus 1 is going to give me 3, meaning the term there was supposed to be minus 1 for us to get this. But we can try if it works. But also, just to confirm, you can try if it works by taking, say, the second term, you plug it there. It's going to be indeed 4 times 2, which is 8 minus 1, which is 7. You can try it with the fourth term as well. You just plug 4 there. 4 times 4 is 16, minus 1 is 15. So it does work. So that's our nth term for this sequence. So this nth term, now that 4n minus 1, you just go there, you plug it, and then it's 4n minus 1. So now you have the value for a n squared plus bx plus c. This is n squared plus 4n. Let me just write it with the same color. So I just wanted to write with the same color there. So the nth term for this sequence is given by this. So this gives us the nth term for this sequence. If you are not sure, you can try it. We can plug, so we have first term, second term, third term, fourth term, fifth term. If we put 1 there, we're going to have 1 squared, 4 times 1, so it's 4. 1 minus 1 is going to give us 4 for the first term. So now let's try it with the third term. Third term is 3. If we put 3 here, we'll have 9. 4 times 3 is 12. 12 plus 9 is going to give us 21. Minus 1 is going to be 20. So indeed, this is the nth term for this sequence. So now we found the nth term of the quadratic sequence using the first method. On the very same sequence, let's use the second method that I told you about. Let's do the things. So using the second method, again, the goal is to represent this sequence in the form of a n squared plus bn plus c. The goal is to achieve this. And now, because we are working with the very same sequence, we expect to get the very same answer as the one we had previously. So now, this is how it works. You denote the constant as 2a. We say 2a is equals to this value. 2a is equals to this value. To get this value for a, we say 2a is equals to the value of the second difference. And then somehow the mathematicians have already derived for you the value for the second difference. So we say for the second difference, 3a plus b is equals to this value. For the second difference, 3a plus b is equals to this value. And then for the sequence itself, we say, and then for the original series, we just say a plus b plus c is equals to the first value. So if you see, everything is assigned to the first value. But first, you have to get your sequence. It's going to be given like this. You're going to get your first difference in this order. You get your second difference in this order. And then after you assign 2a to be the first value of the common difference. Anyway, it's going to be constant, but then you give it like that. And then 3a plus b is equals to the first value of the first difference. This is the second difference. Remember, the first difference from the original sequence. And then the original sequence, a plus b plus c is equals to the first value of the original sequence. All these a, b, c values, they represent a, b, and c here. So now, this one, it looks way easier than the first one, because to get the value of a, we say 2a is equals to 2 from here. 2a is equals to 2, which means a is equals to 1, right? So a is 1. If a is 1, I come here, I write n squared, because a is 1. Now, to get b, I say 3a plus b is equals to 7 from this. 3a plus b is equals to 7, which means b is going to be 7 minus 3a, right? But I know my a is 1, so b is going to be 7 minus 3. I substitute by 1 there. Therefore, I'll have 7 minus 3 is going to be 4, meaning the value for b is positive 4. And then I found my value for b. Therefore, b is 4n. Now, I just have to find the value for c using this. Finding the value for c, I will then say a plus b plus c is equals to 4 according to this. Remember, this is given like that. And I would say c is equals to 4 minus a minus b if I take everything to the other side. Therefore, I'll have 4 minus a is 1 minus b is 4. So 4 minus 1 minus 4, this is going to give me minus 1. Therefore, the value for c is going to be minus 1. So now we're done. The nth term of this sequence, we get this, which is the very same as the way we did with the first method. So you either choose to use this method or the first one. So here we are given a question. I will put the question as usual. The question reads, here are the first 5 terms of a quadratic sequence. And then we have 9, 17, 29, 45, and 65 in that order. And then they want us to find an expression in terms of n for the nth term of this quadratic sequence. So they want us to determine the nth term of the quadratic sequence. Again, I will use the both methods that I show you. I'm going to use method number 1 and method number 2. And then you'll choose which method are you more comfortable with. That's going to be your method throughout. So let's do this one as quick as we can. Here I'm given a sequence. The sequence is said to be a quadratic sequence, and then it goes like this. I have 9, 17, 29, 45, and 65. And then now getting the differences is going to be 17 minus 9, it will give me 8. And then 29 minus 17 will give me 12. And then 45 minus 29 will give me 16. And then 65 minus 45 will give me 20. So this is my first difference. This is my first difference. And it's not constant. Now to get my second difference will be 12 minus 8 will give me a 4. 16 minus 12 will give me a 4. 20 minus 16 will give me a 4. This is my second difference. And then on the first method, I said on my second difference, I must halve my second difference. So I must get half of this. I must have my second distance. I mean, I must have my second difference. And what is half of 4? Half of 4 is 2. So meaning from an squared plus bn plus c. Already for the value of a, I know that a will be 2. So this is going to result as 2n squared. So I'll be having 2n squared as my first term. Now, to get the other two terms, the rule was to say, I take the original sequence as it is, and then I write it here. So my original is 9, 17, 29, 45, and 65. After writing my original, and then I must determine n squared underneath the original, 2n squared. To determine 2n squared, I do it the very same way. I substitute by 1 where there's n. If I put 1 here for the first term, I will get 2 because 1 squared times 2 is going to be 2. And then for the second term, it's going to be, if I put 2 here, 2 squared times 2 will give me 8. And the next one is going to be, if it's 3 there, it's going to be 18. And the next one, if it's 4, it's going to be 4 squared times 2, it's going to be 32. And the next one is going to be 5. If it's 5, 25 times 2, it's going to be 50. So this is our n squared. I mean 2n squared, because that's what we got there, 2n squared for the value of a. And the next step, we subtract. If we subtract here, 9 minus 2 will give us 7. 17 minus 8 will give us 9. 29 minus 18 will give us 11. 45 minus 32 will give us 13. And then 65 minus 50 will give us 15. And then from then, that's when we can get our nth term, our normal way of getting our nth term of arithmetic sequence here. So to get our nth term here, we just have to check our common difference. We can see that our common difference here, 9 minus 7 is going to be 2. 11 minus 9 is going to be 2. 13 minus 11 is going to be 2. 15 minus 13 is going to be 2. So we see somehow it formulates 2n. But then now, this is the value of b. To get the value of c, we ask ourselves, what was the value before the first term? If we were to imagine the value of before the first term, what would be this value here? To get that value, for us to get a 7, what must we add to 2 to get a 7? Obviously, we have to add 5 plus 2 to get a 7 somehow. So we know that the value here, before we get the, it's going to be 5 like that. And you can try it by putting in the first term here. If you put 1 here, 2 plus 5 is going to be 7. If you put 2 here, 2 times 2 is going to be 4 plus 5 is going to be 9. So it works. So this is our nth term for this sequence. So that nth term, we just take that nth term and then we write it here because we got our value for b and c. So this is our nth term for this sequence. This right here. This right here is our nth term for this sequence. If you want to prove it, you can substitute here. To get the first term, if you put 1 here, 1 squared times 2 is going to be 2, and then times 2 plus 5 is 9. It gives us 9. And then you can try it with the third term or any term that you prefer. If you plug 3 there, and then you plug 3 there. Somehow you simplify this, you're going to get 29. So this was the first method. Without wasting time, let's go to the second method. Because you are doing the second method now, I'm just going to leave. Since we are approaching our second method now, I'm just going to leave as it is for now. So for our second method, our sequence has already been broken down. We have the sequence, we have the first difference, we have the second difference. And then the goal is to write it in the form of n squared plus bn plus c. This is when I show the nth term of the quadratic sequence in this form, of this quadratic sequence in this form. So like I say, the first rule is to equate the second common difference, 2a is equals to this value. 2a is equals to this value. And then as it is, you take it as it is, 3a plus b is equals to this value. 3a plus b is equals to this value. And then a plus c, a plus b plus c is equals to this value. So the first values of your sequences, 2a is that, 3a plus b is that, a plus b plus c is that. You just have to remember it like this. And then by solving for a, b, and c, you have solved this. And we expect to get the same answer as the previous one because we're just using the different method on the very same sequence. So now let's go. For this one, 2a is equals to 4. Therefore, a is going to be 4 over 2, which makes a to be 2. So now a is 2. Therefore, I would go there and say my a is 2. So I have 2n squared. Now, to get b, I have 3a plus b is equals to 8, according to this. Therefore, b is going to be 8 minus 3a. Therefore, 8 minus 3, a is 2. This is going to give me 8 minus 3 times 2. That is 8 minus 6. 8 minus 6 is 2. Which means now the value for b as well, the value for b is 2n because b is 2. Now, what is left off is just to get the value for c. And to get the value for c, we have a plus b plus c is equals to 9. Therefore, c is going to be 9 minus a minus b. Therefore, this is going to be 9 minus a minus b. So it's going to be 9 minus a is 2 minus b is 2. 9 minus 2 minus 2 is 9 minus 4, which is going to be 5. So meaning the value for a is positive 5. So, the value for c is positive 5. So where there's c, I put plus 5. So using the second method, we get indeed the very same nth term for that sequence there as the first method. So yeah, you can use the two methods to get the nth term of a quadratic sequence. Otherwise, you can choose which one you are comfortable with. The whole point is to get as many marks as you can in any test, homework, assignment, and whatsoever. I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy. We are your #1 learning platform. Please don't forget to subscribe on our YouTube channel. Please follow us on X, follow us on Instagram, on Facebook, as well as on TikTok. Otherwise, you can now access our learning channel through Spotify. All you need to do is just to go to your Spotify app, search for the word learning channel, or alternatively, you can just search for simplified_RSA. Join me on the next video as we proceed doing some dope stuff to simplify your work academically.